Alright, so what we have here is the simulation software on MATLAB for DAGU 5 degree of freedom arm. What it does is, it first of all calculates the forward kinematics, and then finds out the inverse kinematics and sends out the signal of different angles to the actual robot, side by side also simulating the robot. So you can actually see the simulation and the robot working together in real time. What I've done here is I have hard-coded 4 different locations already in the program, but there is also a version of program which actually accepts the XYZ coordinate of the endpoint effector and the orientation to dynamically calculate the inverse kinematics and find out the angles. So now I'll run it. So the program asks for the location number. Right now I have input 4 different locations, so let's start with location 1. And I'll just shut off the simulation window and now type in location 1, and the simulation has started. So as you can see, the robot arm is right now trying to move towards the object goal. The pink colored dot is the required position where it needs to go. So it's dynamically calculating the inverse kinematics and following the trajectory. You can view the current location of the end effector here in the legend, where it keeps on updating every second, like where the end effector is right now, and then there's also the object location which it needs to find out. As you can see, it's slowly reaching the object location that we had input as, and the robot has reached the final location. Similarly, we can try another location. So as you can see, the program is in loop. So once it has completed one task, it will ask for another location to go. I'll input location number 2, and here we have. So this is location 2, which is, as you can see, it's in the 4th quadrant. If you watch from the top, and the robot is slowly trying to move to that location. It is much above the ground compared to the first location. You can also see the trajectory that the robot has followed all the way to reach the endpoint. And the real-time location of the robot is also being displayed here up in the legend section. So the robot has reached the 2nd location. Now we'll try to make it go to the 3rd location. So I'm putting in number 3 here, and the simulation for 3rd location is started. So this point rests in the 2nd quadrant here, as you can see from the top view. And the robot is slowly trying to find the path and follow the trajectory to reach it, updating the current location right here. So every time what the robot does is goes to the 0 location that is lined up along the x-axis, and then slowly step by step reach the final point using inverse kinematics. And once it reaches that stage, it then asks for the next location to move for. So now I'll just input the 4th location here. And here it shows the trajectory of robot going again to the same place. So just as can be seen in the simulation, in the real time, the actual robot model also does the same thing. Both angles are being calculated at the same time and being fed. And the robot has successfully achieved all the 4 tasks here.